Hello friends, welcome back to the channel. So today we will study the topic cycle of erosion given by Davis. So here I have got a very good PPT presentation and I want to share it in the form of video. So I am sharing this because I was searching for a concept like entropy has been used in the this cycle of erosion theory, but nowhere else is available. And finally, I got this PPT and I got the answer. So I thought ki I should share it with you all so that you can learn from the best material, right? Okay, because basic things are we all aware about the theory, but when exams in some exams like UGC NET, detailed informations are asked about, and we then missed the questions, or uh, we cannot make the answer right. So I hope this video will help you. So let's start. Definition of cycle of erosion, or who developed the cycle of erosion model. Davis conceived the cycle of erosion model in the 1880s. More fully developed by 1900, it received wide acclaim, but was never universally accepted. The initial enthusiasm and strength of the cycle of erosion model has been attributed to various causes. Meaning of the normal cycle of erosion. The cycle of erosion by fluvial processes, running waters or rivers, is called normal cycle of erosion because of the fact that fluvial processes are most widespread, covering most parts of the globe, and most significant geomorphic agent. Even water also plays important roles in glacial and arid regions. W. M. Davis considered humid temperate areas as the most normal case for fluvial cycle of erosion, but this claim is debatable. The normal cycle of erosion begins with the upliftment of any land mass with reference to sea level. As the land rises, the rivers are originated and their erosional work starts. The rate of uplift in the beginning far exceeds the rate of erosion, with the result absolute relief, that is absolute altitude from sea level, and relative relief register increase. After some time, upliftment of the land stops and erosion becomes more active. The land area tectonically remains stable. There is crustal stability for long period of time during which there is neither upliftment nor subsidence of land area. There is progressive development of river valleys in sequential order, and the whole land area progressively passes through three successive stages of youth, mature and old, and is ultimately transformed into low featureless plain of undulating surface. Thus, the penultimate end product of normal cycle of erosion is called peneplain, which is characterized by undulating surface with residual convexo-concave low hills known as monadnocks, unakas, and mozors. So, see here we got the two new terms, that is unakas and mozors. Never read before, right? Monadnocks spelling is I think mistake. Okay, so it will be monadnocks. D is missing here. And unakas and mozors are the final product or end product of the Davis cycle of erosion, or convexo-concave slope, convexo-concave low hills, right? These are all residual convexo-concave low hills. So remember also this phrase, two convexo-concave low hills, they are known as monadnocks, mozors and unakas. Thus, the land area has to pass through the successive stages of its development, right from the upliftment of landmass to its transformation into peneplain of exceedingly low relief. W. M. Davis has divided the whole duration of normal cycle of erosion into three successive stages of youth, that is juvenile, mature or equilibrium, and old or penultimate or senile stage, and each stage has been further divided into three sub stages, that is early, middle and late. For example, early youth, middle youth and the late youth and so on. So every stage is again divided into three: late, early and middle, right? Then thus the landscapes also become young, mature and old with the advancement of normal cycle of erosion. Like landscape development, though three successive stages, the development of river valleys also passes through three successive stages of their development, and rivers become young or youthful rivers, mature rivers and old rivers. Stages of the normal cycle of erosion. The following are the characteristic feature of successive stages of the normal cycle of erosion. So stage 1, that is youthful stage, consequent streams which follow the regional slope are originated with the upliftment of land area due to endogenic forces. In the beginning, the streams are less in number and short in length. Very few tributaries of the master consequent streams are originated. The slopes are dominated by numerous rills and gullies rather than big streams. These rills and gullies lengthen their longitudinal profiles, increase their length through headward erosion. Gradually, the main streams deepen their valleys. The origin and evolution of tributaries of master streams give birth to the development of dendritic drainage pattern. The rivers are continuously engaged in rapid rate of downcutting of the river valley incision because the transporting capacity of the rivers is maximum due to high velocity of flow rate and kinetic energy because of very steep channel gradient. High transporting capacity enables the rivers to carry big boulders, tools of erosion of fairly good size, large size and high caliber angular boulders which help in the pothole drilling of the river beds. It may be mentioned that pothole drilling is the most active and powerful process of vertical erosion, valley deepening in the juvenile stage of the normal cycle of erosion. The valley becomes very narrow and deep with almost vertical side walls due to continuous active downcutting of the valley floors at exceedingly fast rate. The valley side slopes are convex in plan, thus the resultant juvenile valleys are V-shaped and are called gorges and canyons. The valley floors are studded with numerous potholes which are the result of pothole drilling. The interstream areas of water divides land area between the valleys of two major streams are extensive and wide, and these are least affected by denudational processes because valley widening by lateral erosion is less effective in the early and middle youth stage. The valley tholoic, that is longitudinal profiles of the river, is called tholoics, are characterized by numerous rapids and waterfalls which always recede upstream. So you can see that how the content is written, right? So tholoics, if you have to see the meaning, you don't need to go anywhere else. The meaning itself given in the brackets within a very precise words. So that's the beauty of good content. Now most of the waterfalls and neck points disappear by late youth. The rivers are underloaded, not having the required amount of sediment load, not required but sufficient according to their transporting capacity, and thus available energy is more than the work to be done. The rivers are well integrated by the end of youth when maximum relative reliefs are formed. River capture is the most characteristic feature of the juvenile stage of the normal cycle of erosion. Main rivers, so remember this, river capture is most characteristic feature of the juvenile stage of normal cycle of erosion. Main rivers having steeper channel gradients and more volume of water capture smaller streams of relatively low channel gradient through headward erosion. Next, we reached the mature stage. So marked valley deepening through vertical erosion during youthful stage results in pronounced decrease in channel gradient and consequent decrease in flow velocity, with the result the arrival of early maturity is heralded by marked decrease in valley deepening due to decrease in channel gradient, decrease in the velocity of river flow, decrease in the transporting capacity, etc. Consequently, valley widening through actual lateral erosion dominates over valley incision through downcutting. The convex slope of valley sides is progressively transformed into uniform or rectilinear slope, and the gorges and canyons characterized by deep and narrow valleys are replaced by broad and flat valleys. So here is the image. You will easily understand. Already you know, right? Basic concept is clear, I hope. The rivers deposit big boulders at the foothill zones due to sudden decrease in channel gradient and hence marked a decrease in the transporting capacity of the rivers. These materials form alluvial fans and alluvial cones. The gradual expansion of these fans and cones due to their continuous growth result in the formation of extensive piedmont plains through the coalescence of several fans and cones. Interstream areas of water divides are continuously narrowed due to backwashing caused by active lateral erosion and valley widening. Thus, interstream areas are transformed into narrow ridges. The major river erodes down to its base level, that is sea level, and becomes graded. Thus, the longitudinal profile of the master river becomes the profile of equilibrium, wherein there is balance between available energy and the work to be done. That is, balance between the transporting capacity and total sediment load to be transported. Because of marked decrease in channel gradient, the river adopts sinus courses and develop numerous meanders and loops in their courses. Extensive floodplains are formed due to sedimentation of alluvia. Rivers frequently change their course because of gentle to level slopes of the floodplains. Numerous oxbow lakes are formed due to straightening of highly meandering loops. Deposition of sediments on either side of the river valleys leads to the formation of natural levees. Now we come to the old stage. The old stage is characterized by further decrease in channel gradient, almost total absence of valley deepening, decrease in the number of tributary streams, and flattening of valleys. Tributary streams also attain the base level of erosion and are graded. Lateral erosion and consequent backwasting eliminates most of the interstream areas. Valleys become broad and flat, characterized by concave slopes of valley sides. So concave slope is the characteristics of old stage of Davis cycle of erosion. Downcutting of the valleys is totally absent. Weathering processes are most active. Thus lateral erosion, downwasting and weathering continuously degrade the land, resulting into gradual lowering of absolute altitude and water divides. Interstream areas and water divides are remarkably reduced in height and are changed to lowland, but they still rise above the surrounding areas. Transporting capacity of the rivers becomes minimum because of very low channel gradient, and thus the rivers become overloaded. Consequently, sedimentation becomes most active during this stage. The rivers adopt highly meandering courses. The extensive floodplains with level to gentle slopes 2 degree to 5 degree. So remember this slope also the level slope of the plain in the old stage is 2 to 5 degree, and very low channel gradient make the river flow so sluggish that the main channel of the river is divided into numerous distributaries, and thus the river becomes braided. Valley sides are broad, bordered by extensive natural levees, which are also known as bluffs, which denote the farthest limit of recurrent floods of the concerned rivers. Rivers deposit and form extensive deltas at their mouths if the other environmental conditions remain favorable for delta formation. The entire landscape is converted into extensive flat plain of undulating surface, except a few residual convex or concave hills which project above the general flat surface and thus break the monotony of reliefless flat plain called a peneplain. These residual hills, the result of differential erosion, are called monadnocks on the basis of monadnock hills of the northeast Appalachian in New England region. So the term peneplain or monadnock was actually introduced by the Davis cycle of erosion or Davis. The whole landscape is dominated by concave slope, minimum available energy, both potential because of very low height and minimum available energy. Okay, so energy is minimum, both potential because of very low height and kinetic energy due to very low channel gradient. So energy is very minimum, and maximum entropy. So I was in search of this concept actually, ki maximum entropy. What is the meaning of entropy in relation with the Davis cycle of erosion? So I got the easiest answer here. Entropy means maximum disorder of relief. So it is available on the youth stage. Okay, as the whole area is characterized by featureless plain. Maximum entropy means maximum disorder of relief, as the whole area is characterized by featureless peneplain. So the old stage actually characterized by the maximum entropy, or peneplain stage is characterized by the maximum entropy because the disorder of relief is maximum here. This ideal normal cycle of erosion can pass through all these three stages. That is youth, mature and old, and the peneplain can be formed only when the region remains in standstill position for longer duration of crustal stability, but the availability of such condition is of remote possibility because the earth is very much unstable. So this is the criticism. The plate tectonics have also revealed that plates are always mobile and hence long period of crustal stability is not possible. Thus the smooth functioning and completion of normal cycle of erosion is very often disturbed due to tectonic events and also due to climatic changes. So the question actually was what, based on the maximum entropy, I will say it ki the old stage of Davis cycle that is characterized by maximum entropy. So like that, the question was there. Okay, actually it is a statement, so you have to tell that whether the statement is true or wrong. So maximum entropy is for the featureless planes of penny plane, or it is true for the old stage of Davis cycle. Okay, maximum entropy means maximum disorder of relief, and entropy is maximum in the old stage of Davis cycle of erosion. Okay, the disturbance in the cycle of erosion is called interruption of normal cycle of erosion, which is caused by changes in sea level, either due to upliftment or subsidence of oceanic bottoms, or due to glaciation and reglaciation during great ice ages, like Carboniferous glaciation of the Gondwana land during Carboniferous period, and the Pleistocene glaciation of the northern hemisphere during Pleistocene period. Upliftment or subsidence of land areas, volcanic eruptions, and climatic changes. The interruption of normal cycle of erosion by volcanic eruptions or the climatic changes is called accident. The interruptions caused by negative changes in base level, lowering of base level, maximum limit of vertical erosion by rivers due to fall in sea level because of the subsidence of the oceanic floors, and upliftment of land mass are called rejuvenation, which means renewed vigor of erosive capacity of the rivers. Rejuvenated rivers are again engaged in valley deepening at much faster rate, and thus the cycle of erosion is driven back to youthful stage. Several interesting landforms like valley in valley topography. So valley in valley topography is a characteristics of rejuvenated stage of the river, or multi-storied valleys, paired stresses. So remember these names, very important: incised meanders, neck points and neck point waterfalls, uplifted peneplains, deeply entrenched gorges and canyons with broad flat valleys, etc. formed due to rejuvenation. The landforms resulting from several cycles of erosion, whether complete or incomplete, are called polycyclic landforms or multicyclic landforms. Example, Chotanagpur region represents multicyclic landforms. So I think this is the last PDF. Yes, thank you for watching, and definitely all the credit goes to the creator of this PPT, that is the author, and the college it was given in the first slide. Thank you, friends.